Well, we got to bid for certain projects based on which ones we liked, and everybody on the team felt that this was the most exciting one, and we were definitely honored at the opportunity to work with kids. So we really wanted to do something where we could give back and hopefully be able to help children, especially children in hospitals.
We went from like napkin sketches to more detailed sketches, and then from there we just refined it more to developing CAD work and then 3D printing and making parts.
During one of our brainstorming sessions, we were like, circuits. We can model circuits physically, you know, and have kids interact and like model the flow of electrons. And we got really excited, started sketching, and we made the whole thing with clay and like wooden dowels, and we started with that, Play-Doh, you know? That's the basic thing. We wanted to make a physical like representation right off the bat.
So one of the major requirements that we were told from the hospital, we had to have something where there weren't choking hazards as well as something sustainable, so nothing could really get lost so that the toy could function on its own. So we came up with the idea of having everything enclosed so that nothing could go missing and there were no small parts that people could choke on, but we could have small parts involved.
We went to the hospital and then just kind of try to put ourselves in kids' shoes. So I went to the hospital and then I looked at kids there and saw them play, and I have a nephew at home, so I also like just watched how he played, what he liked and what he didn't like. So it was more of an empathy way of trying to get into their shoes, see what they like and design for them.
We found that the kids definitely interact with the toy a lot rougher than we expected. They really like to pull all the knobs and use things in the way that they're not supposed to be used, you know? So there's a lot in learning how kids interact with like the user interfaces. So we have all these knobs coming out of the case, and that was one thing we had to redesign, is how do we present these to the kids so that they know exactly how to use them and not just pull them and break everything.
So there are different things around. So we have a full machine shop downstairs with mill, lathe. There's welding capabilities too. Not that we would need it, but if we did, we could. Over at the ITLL, there's the laser cutters, different 3D printers over there. A lot of tools that I have that I use were my own tools, just from home, different things like that, a lot of hand tools. So different capabilities.
And then we also do a lot of 3D printing, which is a cool new technology that everyone's kind of using right now. And 3D printing is specifically for prototyping. In reality, these parts would be injection molded. That's how like most toys are made. But for prototyping's sake, it's a great tool for us to use that's readily available here on campus.
Because our age range is 3 to 8, it's a pretty big age range, and we figured that the older kids will be able to at least start to grasp some of the concepts, whereas the younger kids will just want to play with the toy. So we wanted something where we could at least start implementing those concrete ideas, as opposed to having it just be theoretical that they could remember it someday. So some matching games, like can you match this with what the actual circuit component is, just seeing if we can start to put 2 and 2 together so that we can have them learn from it in that older age range.
So there's a lot going on right now. Some of it is just finishing up some of the redesign work that we had from our user testing, and then CADing that up, making new drawings, and then just essentially 3D printing all the parts that we need, laser cutting all the acrylic that we need to cut, and machining anything and everything that we need to do for there. From there, it's assembly, and then putting it all together onto our base, and then just finalizing things. So body fill, paint, prime, all that stuff.
The biggest thing was we modeled this after kind of like a Rube Goldberg kind of structure, and that's always, it looks easier than it actually is. There's a lot of physics that goes into it, and just moving a part a little bit actually affects the whole entire functionality. And so going through the prototyping stages, this is our 4th prototype. And so like just in that, like saying that, it takes a lot to get something like that to work.
we came up with several different ideas, several different concepts, and then we settled on this box to model circuits, and then just designed and redesigned, and here we are.
All right.